I am Gnanadesikan. My topic is detecting blindness accuracy in diabetic patient. Introduction. Blindness and service vision implement are the significant global health challenge affecting the million worldwide. According to the World Health Organization, over 2.2 million, including experience same from the vision implement, with a nearly half of the case of beginning preventable or the among the loading cases of the prevented blindness. In detecting reclamation, the diabetes relevant complement the damage, the retrieve the machine of the result particular complement vision lens. The global as a public health issues. DR primary implement the retrieval blood visions. Casing implement recruit skill personnel and splitting increment. The stage of the many decisions of the issues implement occurs to timely damage and cares of the millions patients, including approach the particular device that artificial intelligence deep learning have implement address the challenge for the automatic DR detection. Recent for the according classification DR damage using global dataset. This system prives to implement yearly daily optimization, terminate storage, occurrence outcome. One notable example for the blindness detection involved with the AI device technique, the classification declines the image for the deep learning model designed for the image. For several large screening conflict object of the reliance on the human expression enable the healthcare and prevent of the cases. Executing system and proposed system. Executing system. Traditional medical diabetes. Examination, manual, visual, active test, slit exam and font examination are still the component of the diabetes in the casual settings. According the COT, innovative the technique like optical concurrent technology for acute for the used to the detect retinal and optic nerve damage, affording the including blindness according condition. Automatic relative screen machine like red can yearly retain already integrated to the AI analyst returning image and detecting continent like the responsibility macular which they can the lead of the detecting blindness. Proposed system. Advanced AI based traditional imaging tools. Future system called use AI to analyze confirmation data set, accompanying relational scans with the particular history and lifestyle fact of the predict blindness risk year before the occurs. And the deep learning models for the categories detection machine learning algorithms world not only detecting yearly integrating for the categories but called of predict disease programming for the relational personal terminated. Mobile and wearable technology. Smartphone apps of the blindness detection. Mobile application using AI analyzed the relational for the feedback visual health could make a blindness detecting more assembles for the external role and understanding array apps like Speak Cloud enable the deep AI integration for the categories. Software and hardware requirements, user management and authentication, predicts profile management. The software cloud allow predict of the register and maintenance for the profile with the personal details which the name, age, gender, medical history, family history and blindness of visual implement of the risk factors. Healthcare predictor profile management. Admin for the healthcare predict the sold of the for register automatic and manage the profile. Different accuracy level most private of the based on role. Doctor admins techniques. Search authentication. The system most support multi-factor authentication (MFA) of the role-based accuracy control ensure security, privacy, sensitivity, or protecting data. Architecture design. This suddenly employ advanced deep learning technique to classify interpretation image for the blindness detection. The proposed framework in based on the effect of the architecture and image multiple processing steps, encouraging image quality and optimization method performance. The technology of organization into several stages of the given below. Data input. Load raw relational image of the labels. Image purpose crap blue accuracy. Data argumentation apply random flip model. Conjugation environment with the proof processing. Train with the k-fold validation. Test time argument and accurement of the predictor. Evaluation accuracy. Data processing to private high quality input data compromising the purpose of application image cropping into the used for the cropping image removing the areas such as the black borders. A grainness mask increase only signification reduction of the requirement of the noise. Result and discrimination. The process deep learning framework and based on the effective BO architecture discriminated high accuracy in detecting blindness based of diabetics religion DR. The model was tested on 2019 blindness detection based set. Architecture accuracy 94%, F1 score 96, precision 91%, recall 93%, AUCR 95%. Conclusion. The future of environment. The fitting framework based on the deep learning framework blindness detection highest in strong performance and intelligence for the models. Method for the explanation result for the key matrix search accuracy, F1 score, precision, recall and ACU complication, the reliability, accuracy, classification, image and predictive blindness. Outcome. The high F1 score understand to the model's effective blasting, predictions and recall which the cost of the misclassification in the medical application. The processing of the people's which the including image cropping, cohesion, blindness and was international improvement image qualification enable more effective futures explanation. The use for the data acquisition technique like random, redundant, high flip, encouraged models. Capability for the learning with the property effective B3 effect signification, boosted accuracy, prediction of the limited training data. The test time arguments TTA, future increased prediction, stability and averaging result accuracy argument of the testing image. In confirmation to the baseline models, the proposed framework show signification improvement the birth accuracy, blindness processing, promising solution for the automatic blindness detection. The result for the detection of the framework for real world clinical application for the effective detecting tools for the dynamically medical images. First of all, this coding is Python language using. This image show the Python source code for a relationality detection program including implementing libraries, mounting Google Drive and counting image in the folders. Syntax. Next, def count image folders all. Image occurrence JPG, JPGEG, PNG, PMP, TIFF, GIF. Next one image count. Next one image pair image, melt image, moderate image, server image, profile freight image, image tar bath, flip image, show of the result. Next one show from the data frame. data frame equal to train plus df. Separate in the train and test data. Train underscore tf, comma test tf equal to train test split. Image size flat true random state 1. Tef label. Create on the generate train store the generate train image value image test image equal to create the print. Input equal to predetect underscore model city input. This is the X private model output. PD dot data frame history dot history accuracy value underscore accuracy plat. Print accuracy print show. Next map the label equal to train image dot class including label equal to tech for the k comma vn label items. Predict label k in k predict. Display 5 predicts of the predict print. Finally plt x label recall, plt y label prediction, plt title position recall rate, plt dot legend, plt dot growth, plt dot predicted image show a training and testing dataset of retinal scans used for the detecting diabetic retinal DR. The diabetic retinal is a eye candidate that can causes vision loss of blindness in people without diabetes. The image are classification into different stage of DR. Moderate DR, predicted DR, no DR, mild DR. Predicted image is a bar chart including the number of pictures in each category of the diabetic retinopathy. This distributed dataset which makes requires specific handling during models training to avoid bias. Based on the private image figure 3 integrate the accuracy of the model in detecting blindness accuracy in diabetes patient. The graph show both of the training accuracy and validation accuracy across 5 effective. Training accuracy, validation accuracy. The validation accuracy is generally a better include of the model's performance on the on-screen data. The classification of the fact that validation accuracy is not increased with the training accuracy cloud including overfitting. Overfitting accuracy when a models learn the training data too well including to noise and specific details did not generally will do new unseen data. The graph represents the loss and validation loss of the deep learning models during training. The x-axis represents the effect training cycle and y-axis represents the loss value. Loss blue line, wall loss orange line. This graph is used to evaluate the performance of the deep learning model. The image show retinal scans used for diagnosing diabetic retinopathy DR, a combination of the detect affect the eyes. It is a percentage of a confirmation between the equal of diagnosing to and model's prediction DR security level.